Hey guys, this is Miss Beckham. I'm here to help you out with Unit 9, starting with Lesson 1. Lesson 1 talks all about organic chemistry, and organic chemistry is not organic like you see at the store. Organic means that it's a compound that contains carbon, and so any compound that contains carbon is typically called organic in chemistry. And compounds that contain carbon are very, very common, and in fact, you're made up primarily of carbon. So there are tons of organic compounds all around you and that are used for designing different polymers, different plastics, different resins. Organic compounds, it's just, there are so many uses for them. And so anything that contains carbon is called organic. And in the first lesson, it's mainly just vocabulary. So I'm not going to go over that, but I am going to go over this topic called isomers. And an isomer means that you've got two compounds that are very similar to one another in form. They have basically the same formula. So a formula, for example, when you look at this, if we were to make a formula out of that, there are two carbons here. So we could say C2. And then when you look at the H's, there are 1, 2, 3, 4, 5, 6, C2H6O. That's the formula of this compound whenever you just smush it all together, right? Okay, well, what about this one? And on this one, there are also two carbons, C2, and then 1, 2, 3, 4, 5, 6 H's, and then one oxygen. So these have the exact same chemical formula, right? So isomers have the same chemical formula, but yet they're arranged differently in space. A structural isomer means that they are literally arranged differently in physical space. So if you look at the top one, the two carbons are connected together, whereas on the bottom one, there's an oxygen in between, and that completely changes the identity of the element. If you have one carbon in a different spot, you've got a different compound, and it could look different. It could have a different color. It could have a different melting point. It's crazy what one atom can do. And so even though these have the same number of each type, that's called an isomer, they are spaced out differently, and that's called a structural isomer. Another type of isomer, if you look here, these two compounds have the same formula. It would be C2H2Cl2, right? There are two carbons, two H's, and two Cl's. And then same here. So these are also isomers, the same formula, but they're called cis-trans whenever basically one of the elements is kind of flipped over to the other side. And so normally it happens when you can have a kind of like a mirror, and this chlorine actually is up on top up here. So it's called trans because these chlorines are on the same side, and cis kind of means like the same. And so they're on the same side. These chlorines are on opposite sides. And so it's called trans. So cis trans, you can remember like same versus opposite. It's kind of like a quick way to remember it. And so that's another type of isomer, is whenever something's kind of flip-flopped in that compound. So let's identify, is this a structural isomer or a cis-trans isomer? Structural isomers mean that they're kind of just arranged differently. Cis-trans means that you've got one like maybe on the bottom together and then it flips up to the top. So this is going to be a structural isomer, because as you can see, this is kind of in a completely different spot basically, but it's not cis-trans. It's not like it went up to a different spot. Let's look at this one here. So here we have C double bond C, bromine, bromine. Here we have C double bond C, but look, the bromines are on the same side here, cis. And now the bromines are on opposite side, trans. So this is a cis-trans isomer because first they're on the same side and the bromines are on opposite sides. Cis-trans isomer for that one. Okay, let's look at this one. Is it cis-trans? Is there something that was on the bottom together and now on the top? Well, this is all just one straight line, right? So this can't be a cis-trans example because you kind of need, normally there's a double bond, honestly, and then you've got some things on the same side and they flip up. So this is just a structural isomer. They're the same formula, the same number of carbons, but they're arranged differently. And those are the only examples that you have. These are directly from your lesson. And so go back and see if that makes sense. If you have any questions at all, you can text me or email me, and I'm happy to help you out.